Welcome to Rapidbench. Today we're going to create a complex test bench with over 270 connections using largely only mouse clicks. First we're going to create our project. We're selecting the Dut language as Verilog, and we're going to do a system Verilog test bench today. So we create that project, and now we're going to move over to the connections page. The first thing we'll do is go get our Dut. Now we can browse for that on our system, and once it's selected, Rapidbench will extract the top I/O, and once it does, it will parse for that I/O and then create an instance on the page. You'll see the instance number increase from 0 to 1 in the top bar, and then it will be placed. Now this Dut has a few interfaces on it: a DDR3 interface, an AXI master interface, an Ethernet interface, and a PCI Express interface, as you can see here. Quite a large design. So the first thing we're going to do is try to hook up the DDR3 interface. Now the matching number up there works pretty well when the number is low for shorter names. So since the DDR3 has shorter names, we're going to reduce it a little bit. First, select by clicking the left mouse button and dragging over the signals that we need. And then we're going to simply go and load a user BFM from our system. Now once that's selected, the Rapidbench will parse for the I/O, compare it to the I/O on the Dut, and then do what it can to match that up. Once it's matched up, all the connections are automatically made for you and the instance is placed, as you can see there. So the only thing that wasn't matched was a reset. That makes sense. The next one we're going to go for is the AXI interface. We're going to select a slave BFM, but first let's clean things up and only show unconnected signals, since our Dut is so large, make things a little easier to see. So we're going to try to hook up the AXI master to the AXI slave BFM. This is an AXI Lite, so it'll reduce the number of signals over some of the other AXI BFMs you may have seen. And now we hit load, and the Rapidbench is once again parsing for the I/O and will automatically make the connections that it finds. And it did a pretty good job, only the reset isn't connected. Now the clock got connected, but we want to connect a different clock, so we're going to unconnect that and then move that aside, and again only show unconnected signals to make things a little bit easier. So the next one we're going to hook up is the Ethernet interface. We have a BFM for that as well, so let's left mouse click and then go all the way down and select all those signals, and you can see you can do it in groups. Once all the I/O are selected, shown in yellow, we'll then be able to move back to the top and quickly browse for our Ethernet BFM. We have one of those as well. We're going to select that, and again, once we hit load, Rapidbench is going to parse for all the I/O in that BFM, match it up the best it can to the signal names or I/O names in our Dut, and then automatically connect all of those for us. Once it does, you'll see the connections move up again. It's now at 36, instances 3. That will be updated once it's placed, and there it is. So you can see how it matches them up. If there are things you don't like there, you can certainly always unconnect and reconnect. So right here you see it's done a pretty good job of matching those up, and we once again will show only unconnected signals. And now the last one we're going to be connecting is the PCI Express for our BFMs, quite large. And again, left mouse click, drag down, and we're going to highlight all of those. And once they are completely highlighted, we'll be able to go up and select our BFM for matching. So you can see why this would be helpful rather than trying to match up, because names don't have to be exact, and Rapidbench will do all that work for you. And we're really just using mouse clicks here to create this bench, and not much else. So now that we've selected all our PCI Express, we're going to load that user BFM and browse for it. We have the PCI Express BFM available, and we are going to load that, and it's going to do its best to connect all of those signals to the BFM that we loaded. And once it does, once again you'll see the connections increase, and you'll see the instances increase as well. All we'll be left with after this are some miscellaneous clocks and resets, and we'll hook those up manually and get this bench completed. You can see when the names are quite long and the BFM is large, the matching algorithm has to go through and really make sure it's matching everything up correctly. And as you can see, we changed the color there to make it a little more identifiable from the other ones, and you can do that between all your connections so they can all be a unique color. And if we're happy with that match, which we are, we're going to show only unconnected, and now we are left with. So for the PCI Express, there was one clock which we are going to unconnect that got connected automatically, and we want to connect it a different way. So let's remove that connection and then fold things back up, and now we're ready to complete our connections of clocks and resets. So one way to do that is to bring in a BFM, but you can also use a clock BFM that we have natively in Rapidbench. So we're going to add that instance to the test bench. It comes up with the default name. You can see how frequencies can be changed, etc. We'll go with the defaults. And what that'll do is allow us to, once that's added, that will be placed onto the connections page when we move back. And there are the clock and reset BFMs, which are just simple BFMs that are included, and we can go ahead and finish off our connections for reset and clock. If you did not want to use one of the clock or reset BFMs in Rapidbench, you could also just create a shell of a BFM that you wanted as well. So if you wanted to create one later, you can also use that as a possibility, and what Rapidbench would do is automatically create those I/O, an instance, and a module, and put it on your bench. But that's just another way of doing it. Here we figure let's use the clock and reset controllers that we have natively, and that'll put down something that will actually run as a clock and a reset control in a system Verilog environment in your test bench automatically. So now we just have a few more to connect up. So for the remaining signals, we are going to tie low these inputs, which are not of much use for us in this environment. We can automatically tie those low in the bench. And for the outputs, we're going to explicitly say that there are no connects. If you have signals that are not connected in Rapidbench, once you do a check, it'll point those out as a warning. But if you explicitly say, look, I'm not going to connect those, that'll avoid those warnings coming up. So we're just going to let the bench know, look, we don't want to connect those, and that'll clean things up nicely. So now that we're done, we're just going to go to a few more tabs, the test bench control. These are just control signals. We're going to take the defaults, basic setup, the directory setup. We're going to go with the defaults there. You see that it goes from that reddish color to blue, meaning we've done everything we need to. The last thing we're going to do here is we're going to add the directory path where our RTL lives. And that'll make it easier so that when the scripts are generated, we will automatically have them compile in the proper location of the scripts. So we'll do that for the directory for the BFMs, and we will do that also for the RTL. And this is one way that you can find these paths. The other one is if they exist in different areas, you can always explicitly put the paths next to each item. But if they all live in one place, this is just a nice, easy way to do it. And the scripts that you get, not just the test bench, but the scripts, will all be pointing to the proper place. So once the set of files is downloaded, it'll be ready to go. And we're going to show that. So we save those settings. Now we're ready to check the project. As you see, if it came up yellow or red, you'd have something to worry about, but you see here, it came up fine, no errors, no warnings, and now let's download it. So to download, it's pretty simple. Generate project, and there you go. You hit the download tab and you save it locally. It comes down in a zip file. This has everything you need for your bench. Let's open it up and take a look at what we have. So we're going to export that zip file and extract the files. There's the directory. Go into there and you can see everything we have. Let's take a look at the test bench real quick. If we open up that test bench, you can quickly see this is all the connections are made. Your top is defined. All the settings that were in the bench control are there. And if we just scroll down quickly, we'll be able to see the dot and the placement of all the BFMs are in this bench. Okay, there you have it. You have a test bench with all its connections made, all in less than 10 minutes. But let's just go see that it compiles. We'll bring up Quest2Sim and just run and see that this will compile. And then from there, you can start writing tests and continue with your verification. But less than 10 minutes of loading in a DUT, mostly with mouse clicks, loading in BFMs, having connections made automatically, having a system Verilog bench made with the scripts and a directory structure was fairly painless. There's other things you can do in Rapidbench, like change the instance names rather than going with the defaults. You can change headers and footers so that all the files look consistent with those parameters. And you can also modify the type of language. We did a system Verilog. You can do a simple VHDL, Verilog, UVM. So there's really a lot you can do. Now here what we're doing is just opening up and just seeing that we compile and showing that what was created was compiled correctly. We have a syntactically correct test bench with about 273 connections made and hooked up and downloaded all in less than 10 minutes. Thanks for watching, and for more detail, please watch the other videos.